Hello mga kabady. Today I'm going to show you how to properly check a capacitor. A capacitor is a device that can store electric charge between its plates. When a voltage source is applied, the what happens is that it simply redistributes some electrons from one side of the capacitor to the other, and this process is called charging the capacitor. Charging continues until the potential difference across the capacitor is equal to the applied voltage. Now, it is this capacitor's action that we are going to see when we test the capacitor with an ohmmeter. Now, what does it look like in the ohmmeter when the capacitor is charging? Now, it looks like this. The needle will move towards when you test the capacitor. If the capacitor is good, then the ohmmeter needle will move towards low resistance because the current is flowing. So it will move towards low resistance. Then as the capacitor is fully charged, then the needle will return to infinity or high resistance. So that is an indication of a good capacitor. Now, if ever the needle will move toward low resistance and stay there, the capacitor or moves towards here, maybe 0 or almost 0, then the capacitor could be shorted and needs to be replaced. Now, if the capacitor will or if the needle will not move at all, then the capacitor could be open, and of course it needs to be replaced as well. If the needle moves towards low resistance but then it doesn't return, or if it returns only a little to high resistance, then it could be that the capacitor is leaky. So that means to say that the capacitor also needs to be replaced. So we have here different types of capacitors. We have 3 electrolytic capacitors, 1, 2, and 3. These capacitors are polarized. So that means to say you need to be careful how you connect this to the circuit. So the positive terminal of this capacitor goes to the positive of the power supply. So if you connect this in a wrong direction, then the capacitor will be damaged, and the negative will go to the negative side of the power supply. As you can see, we have here a negative sign printed on the body, and also one leg is shorter than the other leg. So this shorter one is the negative, and this one, the longer one, is the positive. Of course, not all capacitors are the same. So this one, the legs are the same length. This one is the negative, and the other side is the positive. This one is the positive, and this one is the negative. We have here 2 other capacitors. This one is mylar capacitor, and we have here ceramic capacitor. These 2 capacitors are non-polarized. So that means to say that you can install on the circuit without considering the polarity. So because this has no polarity, so it can go either way in the circuit. So let us proceed with testing these capacitors. Let us proceed with this capacitor. Of course, we will be using an ohmmeter. So we have to take note when using the ohmmeter. When using the ohmmeter, the polarity of this test probe are reverse. So that means this is now negative and this is positive. So the red will be negative and the black test probe will be uh, positive. So we'll measure now. So how to do this properly? The red should be connected to the positive and the black to the negative. So, by the way, we'll need to select a proper range. For what this is 1000 microfarad. So I guess times 10 will do. Times 10. Okay, again the positive. Okay, this one is the negative, so this goes to this negative side. Okay. Did you see that? Did you see the needle? It moves towards low resistance and return to infinity. Fully return to infinity. Now, if it cannot fully return to infinity, say it only here, then the capacitor is leaky. No? So again, we'll do it again. To discharge the capacitor, we'll connect this the opposite direction. Okay, then connect once again to the proper direction. Again, it moves towards low resistance and return to infinity or high resistance. So this capacitor is good. How about this one? This is 330 microfarad, 200 volts. So again, then negative. This one is the negative, as you can see in the printed on its body. This is negative. So we'll connect the red test probe. Okay, did you notice it? Okay, so I will discharge this first. Discharge and charge once again. So again, it moves towards low resistance and quickly return to high resistance or infinity. So this capacitor is very good, no? It's charging. How about this one? This one is, I think this capacitor is damaged, but of course we'll try to prove if this capacitor is really damaged. This one is 330 microfarad, 10 volts. So we'll try this with times 10. Okay, so nothing happened. The needle did not move at all. Reverse. The needle didn't move at all. So we'll use, it's supposed to move because this is 330 microfarad, just like this one. This one is 330 microfarad. It's supposed to charge to move the needle. So we'll try times 100. So I guess this is open. The good practice is to always adjust to 0. Okay, no movement. Again, no movement. It only moves a very little. We'll use times 1k. It moves very little. So this capacitor is bad. And it moves very little and it does not return to infinity. It does not fully return to infinity. So this capacitor is really bad. How about this one, Mylar capacitor? We'll test with times 10k. Of course, if you use times 10 or times 100 to mylar capacitor, surely it will not move. The needle will not move an inch. As you can see, no movement at all because the capacitance value is very small. I think this is only 220 nanofarad. Printed on its body is 224. So meaning 0.22 microfarad or 220 nanofarad. So I will use the highest range of our ohmmeter times 100. Yes, 100K. So I will use that. Adjust to 0. Okay, test. Okay, moves towards low resistance and fully return to high resistance. That means this capacitor is charging. Yes, a very good indication that this capacitor is doing well. By the way, when you test this capacitor, please be careful not to disconnect the test pins to the uh, leads of the capacitor. Of course, if you disconnect, of course, the needle will surely return to high resistance. How about this one, ceramic capacitor? It moves towards low resistance and return to 0 or high resistance. Again. Oh, no, no, no. Okay. So I think the capacitor is also good because it moves towards low resistance and return to 0. Now, I have here another meter which we are going to use to confirm our reading, our resistance reading about our capacitors. So we're going to test the capacitance of these capacitors. If these capacitors are really good. So now I'm using the capacitance meter. So I hope you can see it. Okay, first we're going to test. By the way, this meter is auto range. So now first we're going to test this 1000 microfarad. Okay, so I hope you can see it. 1000 microfarad. OL. Oh, the reading is 1.124 millifarad. So that means this is 1124 microfarad. So this capacitor is good. The other one, this 330 microfarad, 200 volts. Can you see it? 330 microfarad, 200 volts. So I hope you can see it. And we have 306, 320, 324, 326, 329, almost 331.6. Yes, this is 331.6 microfarad. So this capacitor is also good. How about this one? This one, according to our emitter reading, this capacitor is bad. So we're going to double check with our capacitance meter. Okay, so I hope you can see it. But the reading is 1.43 nanofarad. So the value is very, very small. 1.45 nanofarad. When in fact, the value of this capacitor is 330 microfarad. So that is why this capacitor is really bad. Because the capacitance is 1 nanofarad more. Yes, 1 nanofarad, more than 1 nanofarad, but then the real value of this capacitor is 330 microfarad. So this capacitor is really bad, as confirmed by this meter and also by our ohmmeter. So this one 220 nanofarad, so ceramic or mylar capacitor, 233.7. So if this is yes, this capacitor is also good, 220 nanofarad. Our reading is 233. That is still acceptable. If this is the capacitor has tolerance, maybe more than 10%. So this one is acceptable, good capacitor. We have the last one, the ceramic capacitor. According to our according to the value printed on its body, this is 100 nanofarad. So we'll measure. I hope you can see it. 93.7 nanofarad. So this capacitor, if the tolerance of course is 10%, so it is within the range. So this capacitor is also good. So kabady, that is how we test our capacitor, if it is good or bad. We just have to understand how the capacitor works. Just remember that the capacitor, the capacitor's function is to store charge. Then of course when the value is equal, or when the charge is equal to the voltage applied, so it will stop charging. That is why the needle will move towards low resistance and then it returns to high resistance or infinity when it is fully charged and stop charging. So that's all for today. Bye bye.